Okay, sorry. Had a problem with our windows. We've been living without air conditioning since it's been so cold outside. Okay, let's go back to where we were. We had this reaction of 2 moles of sodium azide solid decomposing very rapidly and producing 2 moles of sodium metal liquid and 3 moles of nitrogen gas. We want to find out how many grams of sodium metal are produced when or per liter of nitrogen gas produced. Let me see here. Yeah, I'm okay. Just to make sure it fit on the screen up there. Okay, let me turn off this fan to make sure people can hear me on the recording. Okay, so let's see here. How many grams of sodium liquid metal are produced per liter of nitrogen gas formed in the decomposition of sodium azide if the gas is collected at 25 degrees Celsius and 1 bar, pressure of 1 bar. All right. So think about that for a minute. What do we need to do to get from nitrogen gas over to sodium metal? Hopefully you said to yourself that we need to get moles of sodium so that we can switch to we need to get moles of nitrogen gas so we can switch to moles of sodium metal, and then we can use the molar mass of sodium to switch to the number of grams. And we are going to use pervnert. Get a pen. N is what we're looking for, the number of moles of nitrogen gas. And that will equal pervert. It'll be the pressure times the volume divided by R times T. And what does it mean per liter of nitrogen gas? How many liters would that be? Every time you see the per liter of this or per gram of that, it means 1. So we're going to use 1 liter of nitrogen. We're going to use the gas constant of 0.08314 bar liters per mole Kelvin. Okay. We're going to change 25 degrees Celsius to 298, since that's room temperature, by adding 273.15, getting 298.15 Kelvin. Sorry about the crowd. So we have the pressure, we have the temperature, we have the volume, not that kind of volume, and we have the gas constant. I'll give you a second to write that down. Okay, going to the next page. So we have N equals pervert. The pressure is 1 bar. The volume is 1 liter. The gas constant is 0.08314, and the temperature is 298.15. Put too many nines there. So we have 1 bar. Since it's per liter, we have 1 liter. So we punch that in. 1 divided by, don't forget to open parentheses, there are 2 numbers on the bottom. And we get a small amount of metal. Most of what is produced is nitrogen gas. That metal does need to be protected when the nitrogen gas is formed because of the fact that it's sodium and reacts highly and violently with water. What'd you get, Nick?
I got 3,586.1.
So you took 1 and you divided it by, open parentheses, 0.08314 times 298.15.
Oh, I think I did it wrong.
What'd you get, Courtney?
I just realized I did it wrong.
What did you get, Rebecca?
I got 0.040.
Okay. 0.04 moles of nitrogen gas, sodium metal. No, nitrogen gas, doofus. Excuse me, let me erase that part. So we have 1 liter of nitrogen gas. It was at 1 bar, and the gas constant was 0.08314. It was at 25 degrees Celsius, room temperature, 298.15, and it was a small amount of moles of gas. It was 0.04 moles of nitrogen gas. Anybody else agree with that? Just say me. Me. All right, going back to muting for a moment. Okay, so now that we have the moles of nitrogen gas, we can go 0.04 moles of nitrogen gas. And we want to get over to the nitrogen or the sodium metal, so we're going to use the molar ratio from the balanced equation of 3 moles of nitrogen gas to 2 moles of sodium metal. We will cancel the moles of nitrogen gas, and we are now in moles of sodium metal. We look at the periodic table. We're going to write 1 sodium is 22.99 grams per mole. Don't forget to show your work when you're doing molar masses or formula masses. Don't forget to show your work when you're changing units to some other units so that are because of the gas constant. And we're going to put the 22.99 grams per mole of sodium metal like that. And that way we'll cancel the moles of sodium and we'll end up in grams. So when you finish writing that, you'll punch in 0.04 times 2 times 22.99, entered, divided by 3, enter. And you should get the correct answer. Maria Elisabeth, what did you get?
I got 0.613.
0.613 is correct, or at least that's what I got. Hopefully great minds think alike, or punch in the keys correctly. Any questions at all about that one? Okay, no questions. Does anybody need more time to copy? All right. Going back to a new screen, we're going to start something new today. We're going to talk about the mole fraction. Mole fraction means it's a ratio of a certain number of moles to a certain number of moles. We use a symbol, X, subscript capital A, is the symbol for the mole fraction. And the mole fraction is the number of moles of a particular gas in a mixture ratioed with, or making a fraction of, the number of moles total in that mixture of gases. Just take a moment and remember John Dalton and his idea of, or his law of partial pressures, that the pressure total of a mixture of gases is equal to the individual pressures, what we call partial pressures, of gases involved or contained in the mixture, and many others if possible, or if necessary. So it can be 2 gases, 3 gases, 4 gases. Air, for example, has 4 gases in it mainly. It's 78% nitrogen gas, 18 to 21% oxygen gas, 0.9% argon gas, and the smallest amount of gas in the atmosphere is carbon dioxide, 0.04%. The mixture we're going to talk about will be helium and hydrogen, but from Pervnert, I want to show you another ratio that appears, and that is that we can take the partial pressure of a particular gas and ratio it with the total pressure of a mixture of gases, and we can use that equal to the ratio of the moles of that particular gas to the total moles in the mixture. We can also take the volume of a gas in a mixture and ratio it with the total volume. These 3 ratios, or fractions, allow us to sometimes save time in calculations and give us a little bit of a shortcut. For example, we are going to first use Pervnert to solve for the pressure total of a combination of hydrogen gas and helium gas. So we're going to have a mixture of hydrogen gas and helium gas. They will have individual partial pressures equal to the total pressure of this mixture. And we're going to use 1 gram of hydrogen gas and 5 grams of helium gas. Okay? 1 gram of hydrogen gas and 5 grams of helium gas. The first thing we're going to do is we're going to change these amounts in grams to moles so that we can get a total mole amount to put into Pervnert. also given information that the volume of this mixture of hydrogen gas and helium gas is 5 liters, 5.0 liters. And that this gas is at a temperature of 20 degrees Celsius. Okay. Give you a second to copy that, and then we'll go on to the next page. Everybody ready to move on? Does anybody need more time? Anybody need more time? Okay. All right, moving on. So, we're going to take 1 gram of hydrogen gas. We're going to take a moment to look at the molar mass of hydrogen. 1 hydrogen is 1.008 grams per mole. We're going to double that because we have the molecule hydrogen gas, one of the diatomic gas, 5 diatomic gas molecules at room temperature, H2, N2, O2, F2, Cl2. Don't forget you're supposed to be memorizing those. And that'll give us 2.016 grams per mole of hydrogen gas. We have 5 grams of helium gas and 1 helium on the periodic table. Look at your periodic table that you have is 4.00 grams per mole of helium. Okay? I'm going to move this over a little bit. Right here we're going to take the 2.016 grams per mole of H2. We'll cancel the grams per mole. And you'll divide the 1 by 2.06. 0.16. Not sure what I said. And you get 0.496. We're going to go ahead and round that to 0.5. You'll see why later, just to make it easier later. And that's 0.5 moles of hydrogen gas. Then we're going to take the 4 grams of helium gas, and we're going to take its, it's 5 grams, isn't it? Let me erase that. So we're going to take the 5 grams of helium gas, and we have 4 grams per mole of helium gas, its molar mass, and 5 divided by 4 is 1.25. Moles of helium gas, which gives us a mole tot of 1.75 moles of gas in this mixture. So we use the amounts in grams, change them to moles, added them together, and we now have mole tot, total moles. We're going to be looking for pressure, which will be nRT. And we have a volume of 5 liters. We now have a total moles. The volume is also V tot. It's the total volume. All the gases are in that one 5-liter container, or both gases are in that 5-liter container. We have the total moles in that container. It's 1.75 moles of gas, combining the 0.5 of hydrogen gas and 1.25 of helium gas. Temperature was 20 degrees Celsius. Put 273.15 to that. We end up with 293.15 Kelvin. So now we have the volume, we have the number of moles, we have the temperature, and we are using the gas constant of R equals 0.08314 bar liters per mole Kelvin. Any questions? Any questions? Anybody need more time on this? No? Okay. Alright, so we're going to the last page. And we're going to put pressure equals inert V. We have 1.75 moles of gas times the gas constant. We're going to multiply that times 0.08314. We're going to multiply that times 293.15 Kelvin. We're going to divide it all by 5 liters of gas. So grab your calculators. Punch everything in. Gives us 8.53. I'm going to use 8.5. You'll see why in a moment. Makes it easier down the line. You could also use 8.53. It wouldn't matter. And that is 8.53 bars. I don't think I've ever been to 8.53 bars in my life. Not in 1 hour anyway. I had an uncle who was a magician. He was walking down the street and turned into a bar. Are there any questions? All right, now we're going to use the mole fraction to solve for use the mole fraction to find the partial pressure of each gas. The first mole fraction we'll use is the number of moles of hydrogen gas divided by the moles total will equal the partial pressure of hydrogen gas over the total pressure. So we're using two of the ratios that we talked about. And we have the number of moles of hydrogen gas over the number of moles of total moles is equal to the partial pressure of hydrogen gas. The total pressure we have is 8.5. The number of moles of hydrogen gas was 0.5. The number of moles total was 1.75. So you cross multiply 0.5 times 8.5 equals 1.75 partial pressure of H2. And you divide the answer you got from the first two numbers by 1.75 and you'll have the partial pressure of hydrogen gas. Then we're going to take the number of moles of helium gas divided by the moles total, and that will equal the partial pressure of helium gas divided by the pressure total being 8.5, the moles total being 1.75, and the moles of helium being 1.25. And there you will cross multiply 1.25 times 8.5 equals 1.75 partial pressure of He, helium gas. You'll divide the answer of the first two numbers multiplied together by 1.75 and you'll have the partial pressure of helium gas. So write those two out like I did and get a number for the partial pressure of hydrogen gas and the partial pressure of helium gas. We're going to go with 2.43 here. Here we're going to go with 6.1. So we could use 2.4 and 6.1, round to tenths on each one. And that'll give us the total pressure of 8.5. Are there any questions? Any problems getting these answers? Any questions? Does anybody need more time in calculating or copying this down? I guess I better do this first. Okay, listen carefully. Right now I need you to send me your notes, picture of your notes, and you're going to write in the subject bar, notes for. Hang on one second, let me assign the homework first. Stop moving for a minute, sorry I said that. Stop moving and listen for a moment. I should have said the other thing first. Okay, so the homework, let me give you the homework first. The homework is 612A, and this will be homework 4, and it'll be 6-12A. Alright, that is a problem using a mixture of gases. You're given the moles of the two gases, you combine them to get total moles, and then you're given the partial pressure, you're given the temperature and the pressure, and you find out the partial pressure of each gas. You do not have to use per inert, you can use the mole fraction like we just did. That's 612A. Now today I want you to send me your notes and put in the subject bar notes 4 and period G. When you send the homework, put period G also. You don't have to write 612A on it. I'll know which one it is. Now, are there any questions?
When is the homework due?
When is what due? The notes are due right now, and the homework is due the next time we come to class.
Thank you.
Okay? Anybody else? We are done for the day, folks. Have a nice holiday. 3 days off. And if there are no questions, send me your notes, and I'll see you next week.
Thank you.
Thank you.